So now I will teach you shortest remaining time first algorithm. So it is somewhat similar to SJF algorithm, but the difference is that SJF is non-preemptive and SRTF, shortest remaining time first, is preemptive algorithm. What is preemptive algorithm? Preemptive algorithm means what? If a process is running, it may be possible that in the middle of its execution, even before the completion of its task, the CPU can be snatched from that process and can be assigned to other process. That is preemptive algorithm. I already told you. So here in SRTF algorithm, what will happen? Suppose if a process is running and in the middle of its execution, another process with lower burst time comes. With another process with lower burst time comes, then CPU will be snatched from the current running process and will be given to that process with lower burst time. But it doesn't mean that the task of the current running process is finished. I think you are not getting it, but with the help of example, it will be more clear. You see here, so it's better to solve this example. Okay, so things will be more clear to you. So here's, you see what will happen. Let's draw a Gantt chart. Now you see, at t is equal to 0 second, how many processes are available? At t is equal to 0 second, only one process, P1. Because only P1 came at t is equal to 0 second. So P1 is here. So after running for 1 second, P2 came. Okay. So at t till t is equal to 1 second, from 0 till t is equal to 1 second, how many processes are available? P1 and P2, because P2 came at t is equal to 1 second. So here I will write P2 also. So now you will see, among P1 and among the available processes, it means what? P1 and P2, which process has the lower burst time? Obviously P2 has the lower burst time. P2 has 5 and P1 has 7. So here I will write P2. And since P1 executed for 1 second, so how much time it has left? How much burst time it has left? It has left 7 minus 1 is equal to 6. 7 minus 1 is equal to 6. Because P1 has already executed for 1 second. Now it has 6 seconds left. Okay. So here you see preemption is happening. P1 has not yet finished its task. P1 is still available. But CPU is switched from P1 to P2. Why? Because P2 has lower burst time than P1. Okay. Now P2 will run for another 1 second. It means what? 1 plus 1, 2. So by this time t is equal to 2 seconds, how many processes are available? You see, from 0 to 2 seconds, 3 processes will be available. P1 is already there, P2 is already there, now P3 is there. Because P3 has arrived at t is equal to 2, now P3 is there. Okay, and P1 has not yet finished its task because P1 was to be executed for 5 seconds, but it executed just for 1 second. So here it will be 5 minus 1 is equal to 4 seconds. Okay, 4 seconds are left for P2. So now P3 came. So how many processes are available now? P1, because P1 it's still remaining. It has 6 seconds left. 6 seconds left. P2 has 4 seconds left, and P3 has 3 seconds left. P3 has 3 seconds. So among these 3 processes, which process to select? Obviously P3, because P3 has the lowest burst time. Okay, so here I will schedule P3. And after running for 1 second, it means from 2 to 3. So how many, so at t is equal to 3, you see P4 has come. At t is equal to 3, you see P4 has come. So how many processes we have? How many available processes we have? P1 is left, P2 is left, P3 is left, and P4 has come at t is equal to 3 seconds. So you see this P3 has executed for 1 second. So how much time it has left for execution? 3 minus 1 is equal to 2. So now among these 4 processes, which process has the lowest burst time? 6, 4, 2, 1. 6, 4, 2, 1. Which process has the lowest burst time? P4 has the lowest burst time. So here I will schedule P4. Okay. So now, since the burst time of P4 is only 1 second, and after executing for 1 second from 3 to 4, it means what? The job of P4 is done. It means what? It had only 1 second as burst time, so it executed for 1 second. So 1 minus 1 0. It means what? The job of P4 is done. So now P4 is not available. P4 has completed its task. Okay. Now you see at t is equal to 4 seconds, which process came? P5 came. At t is equal to 4 seconds, P5 came. So what are the available processes? P1, P2, P3. Don't count P4 because P4 has already executed its burst time. Okay. So what are the available processes now? P1, P2, P3 and P5. P1, P2, P3 and P5. Okay. Is it visible? Okay, fine. So here P5. So we have four processes: P1, P2, P3, P5. So among these 4 processes, which process has the lowest burst time? P1 has 6, P2 has 4, P3 has 2, and P5 has 2. So you see, 2 is the lowest burst time, but here P3 and P5 both has 2 seconds left. So which process, so CPU should be allocated to which process? There is a tie between P3 and P5. So in order to resolve this tie, there is a condition that if a process arrives earlier during the tie, if a process arrives earlier, then that process should be given a CPU. It means what? Among P3 and P4, which process came earlier? P3 came earlier. So CPU will be given to P3, not to. So among P3 and P5, which process came earlier? P3 came earlier, so CPU will be given to P3. Because P3 has arrival time of 2 and P5 has arrival time of 4. So CPU will be given to P3, not to P5. So here again P3 will come. Okay. And after executing 1 more second from 4 to 5, how much time that P3 has left? Initially P3 had 2 seconds. Now P3 further executed for 1 second. So P3 has now 1 more second left. Okay. So 2 minus 1 is equal to 1. So now at 5th second, which process came? Process P6 came. Okay. So now what are the available processes? We have P1, P2, P3, P5, P6. Okay. Now among all these processes, which process have the lowest burst time? Definitely P3 and P6. P3 and P6 has the lowest burst time because both have 1 second left. But since there is a tie between them, so we will see which process arrived earlier among P3 and P6. P3 arrived earlier, So P3 will further execute for 1 second. So now this 1 second was left, so it is executed. So now the task of P3 is completed. Okay, so here we remove P3 also. So how many available processes we have? P1, P2, P5, P6. So till from 0 to 6 seconds, you see all the processes are available. Okay, and P3 and P4 task is already done. So available processes are P1, P2, P5, P6. So from here we will simply apply shortest job first algorithm, which is preemptive. You see how among P1, P2, P5, P6, P1, P2, P5, P6, which process has the lowest burst time? P1, P2, P5, P6. P6 has the lowest burst time. Okay, because these two processes P3 and P4 has already been completed. So we will just check P1, P2, P5, P6. P6 has the lowest burst time. So here I will write P6. And P6 will execute for 1 second. You see. So after execution of 1 second, 1 minus 1 is equal to 0. P3's task is done. So P6 task is done. So here I will remove P6. So how many available processes we have? P1, P2 and P5. So among P1, P2, P5, P5 has the lowest burst time because P1 has 6, P2 has 4, P5 has 2. So P5 will be scheduled. So since I have told you that from this onward, you simply apply SJF. So just simply apply SJF. So P5. So P5 has 2 seconds left. So P5 here run for 9 seconds. So P5 here run for 2 seconds. It means what? 7 plus 2, 9. So now the task of P5 is also done. Okay. Now P5 is also completed. Now the available processes are P1 and P2. P1 and P2 are available processes. So P2 will be scheduled as P2 has lower burst time. P2. So among 6 and 4, 4 is shorter. So P2 is scheduled. So P2 will run for 4 seconds because it has 4 seconds left. So 9 plus 4, 13. Here 4 minus 4 is equal to 0. So P2 is also done. Now P1 is left. So P1 will be scheduled at the end. How much time is left? 6. 13 plus 6, 19. P1 is also completed. So here you see how SRTF algorithm works. Okay. So it has one disadvantage if you compare with shortest job first is that there are lots of context switching happening. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of context switching is 5. So here now let's calculate the turnaround time and waiting time. So first write here completion time. Then we will calculate turnaround time. Then we will calculate waiting time. Okay. So you see, what is the completion time of process P1? So start from the very right side. Okay. Start from the right side. So the completion time of P1 is 19 seconds. Completion time of P2 is 13 seconds. Okay, let me draw a line here. Else you may get confused. The completion time of P3 is 6 seconds. Okay, if you see from here, P3 is completed at 6 seconds. Then for P5, it's 9 seconds. And for P6, it is 7 seconds. Okay. So here we have write the completion time. So let's calculate the turnaround time. What's turnaround time? Completion time minus arrival time. Completion time is 19 for P1 and arrival time is 0. So turnaround time is 19 minus 0 is equal to 19. For P2, turnaround time 13 minus 1. 13 minus 1 is equal to 12. For P3, it is 6. Oh, I forgot to write the turnaround time of P4. The completion time of P4 is 4 seconds. Okay. So now calculate the turnaround time of P3. It will be 6 minus 2 is equal to 4. Now for P4 it is 4 minus 1 is equal to 3. Then for P5 it is 9 minus 4 is equal to 5. And for P6 it is 7 minus 5 is equal to 2. Okay, so these are the turnaround times. So now calculate the waiting time. What I told you about turnaround time minus burst time. So what is the burst time of P1? Turnaround time minus burst time. It means what for P1? Turnaround time is 19 seconds minus what is the burst time? Burst time is 7 seconds, not 6 seconds. After calculation, here we got, these were just calculation parts, so don't consider this. Okay, here I am removing this, else you may get confused. Okay. So 19 minus 7 is equal to 12. 12 is the waiting time of P1. What is the waiting time of P2? 12 minus 5 is equal to 7. What is the waiting time of P3? 4 minus 3 is equal to 1. What is the waiting time of P4? 3 minus 1 is equal to 2. Then for P5, 5 minus 2 is equal to 3. And for P6, 2 minus 1 is equal to 1. So these are the turnaround time and waiting time for these processes. Okay. Is it visible? I think yes. Okay. So I think now it's clear to you how to what is SRTF algorithm. And another important thing is that about response time. So here, okay, let me write here 7, 1, 2, 3, 1. This is a waiting time. Okay. So here I will write response time. RT means response time. So what is response time? Response time is that after the process entered this ready queue, here you see the process P1 entered the ready queue at 1 second, and it got scheduled at, sorry, P1 arrived at the ready queue at 0 second, and it immediately got scheduled at 0 second. So response time of P1 will be 0 minus 0 is equal to 0. Okay. Okay, just wait. I think I've made some calculation mistake. One 19, 12, here I think I've done some mistake. Completion time, completion time minus, oh, here you see completion time minus arrival time is the turnaround time. So I've done 4 minus 3. For P4 it will be 4 minus 3, sorry, it will be 1. So I'm very sorry for this. It's taking a lot of time in this. 10, 12, 4.52, and here it will be 12. Here also see I made one mistake. In waiting time it will be 19 minus 7. Turnaround time minus burst time. So 19 minus 7 it will be 12. Okay. Then let's check it out. 12 minus 5 is equal to 7. 4 minus 3 is equal to 1. 1 minus 1. So you see here, it will be 1 minus 1 is equal to 0. 1 minus 1 is equal to 0. Then 5 minus 2 is equal to 3. And 2 minus 1 is equal to 1. Okay. So I'm very sorry for this. So now let's calculate the response time. So you see, what is the response time of, just wait. What is the response time of P1? P1 arrived at t is equal to 0 second and immediately got scheduled at t is equal to 0 second. So response time of P1 is 0 minus 0 is equal to 0. Okay. Here directly I will write. It means what? Just after entering the ready queue, P1 immediately started to give response, immediately get scheduled. What is the response time of P2? You see, P2 arrived at 1 second and immediately got the CPU. It means what? Just arriving at t is equal to 1 second, it starts responding immediately. So, what is the response time of P2? 1 minus 1, 0. What is the response time of P3? Arrived at 2 and immediately got scheduled at 2. Okay. So, it will be 2 minus 2, 0. What is the response time of P4? P4 arrived at 3 and got scheduled at 3 immediately. So, it will be 3 minus 3, sorry, yes, 3 minus 3 is equal to 0. What is the response time of P5? So, P5 came at t is equal to 4 but got scheduled at t is equal to 7. So, what will the response time of P5? 7 minus 4, because although it arrived at t is equal to 4, but it started responding at t is equal to 7. So, what is the response time of P5? 7 minus 4 is equal to 3. Okay. And what is the response time of P6? P6 arrived at t is equal to 5 and P6 immediately P6 got its CPU at t is equal to 6. So, P6 arrived at t is equal to 5 but got scheduled at t is equal to 6. So, what is the response time of P6? 6 minus 5 is equal to 1. So, it's all about response time. Now, you are getting what is the meaning of response time. Response time means what? Since after entering into the ready queue, the time at which the process starts to give response, that process first time gets scheduled, that is called response time. Okay, but in case of non-preemptive scheduling algorithm, both waiting time and response time are same. But you see, since it's a preemptive algorithm, here response time and waiting time both are different. You see. Okay. So this was all about shortest remaining time first algorithm. And also from here you can find the number of context switching. CS means what? Context switch. How many times the processor has to switch, CPU has to switch? 1, 2, 3. Just count these vertical lines. Don't count this and this. In the middle, how many vertical lines are there? 1, process P2 to process P3. One time. Process P3 to process P4. Again, one time. Process P4 to process P5. Process P4 to process P3 again. It's one time. Process P3 to P3. Here you see, here context switching is not happening. Okay, because here CPU has not switched to other process. CPU is remaining with P3. Okay, here you can feel like this. CPU is with P3. Okay, so here you will not count as context switching here. Okay, let's again start from the very beginning. How many context switching is there? From P1 to P2, it is 1. From P2 to P3, it is 2. From P3 to P4, it is 3. From P4 to P3, it is 4. From P3 to P6, it is 5. From P6 to P5, it is 6. From P5 to P2, it is 7. From P2 to P1, it is 8. So you see there are 8 context switching. 1, 2, 3, 4, 5, 6, 7, 8. So this is a disadvantage of this shortest remaining time first, because there are lots of context switching happening.